In this question, we've titrated a base, ammonia, with HCl, a strong acid. So we identify the salt as ammonium chloride. Now in that salt, it's the ammonium ion that's going to react with water, the NH4+. The chloride ion, of course, would not react with water, being the conjugate base of a strong acid, but the ammonium ion, being the conjugate acid of a weak base, will react with water. So you need to write the chemical equilibrium for that. And then, of course, you want to fill in the IREC table. And for that, you need to know the number of moles of salt that you have. Moles of salt would be equal to the moles of base that you started out to neutralize. So if we take the information in the problem, we have 25 milliliters of base, 0.025 liters, at a 0.1 molar concentration. So that's 0.0025 moles. And that would be equal to the number of moles of salt that we have at the equivalence point. So that number goes into the initial line of the IREC table. Again, we start with the idea that there's zero dissociated product, which of course is never true, but it allows the table to generate the correct equilibrium amounts for us. We have X moles of each product formed, we lose X moles of the reactant, and so we have final equilibrium amounts as shown. We can convert these to concentrations by dividing by the total volume, which must include not only the volume of ammonia that we started with, but also the volume of titrant of HCl that is added from the burette. We can start by calculating that total volume. It would be, remember, the sum of the volume of ammonia at the beginning and the volume of HCl that comes out of the burette. We know this value already to be 25 milliliters. The volume of HCl we can calculate because we know the number of moles of HCl we need. That's the number of moles of ammonia that we have, so 0.0025 moles. And then we divide that by the molarity of the HCl that we're given in our burette. So we find that we need 25 milliliters of HCl. Now the total volume would be the sum of those two volumes. So 25 milliliters plus 25 milliliters, so that would give us 50 milliliters, or 0.05 liters. If we get back now to the equilibrium, we can solve for X by using the Ka expression. This is a Ka because on the product side we have an H3O+. Ka for the ammonium ion is equal to the molarity of H3O+ times the molarity of ammonia divided by the molarity of the ammonium ion. So products over reactants. In this case, the two products have the same molarity, so we can write that as H3O plus molarity squared divided by the molarity of the ammonium ion. Remember, this is only when those two values are equal. Now to solve for the pH, we will isolate the H3O plus molarity on the left side of the equation. That will be equal to the Ka of the ammonium ion times the ammonium ion concentration, and take the square root of that value. We will have trouble finding the Ka of the ammonium ion, but we can easily find the Kb of ammonia. And so we can get the Ka by dividing 10 to the minus 14 by that Kb. As for the ammonium ion concentration, we take the equilibrium moles and divide by that total volume that we found earlier. The equilibrium mole still has the value X in it. We can simplify that by writing the moles of ammonium ion are equal to 0.0025. We do this under the assumption that the X value, the value of X, is much smaller than the value 0.0025, so that 0.0025 minus X is approximately equal to 0.0025. We take the square root of all of that and we get a molarity of H3O+. And from that molarity, we take minus the log of that value to generate our pH, an acidic pH as we expect.